Anyone online? Hi guys. The chat box is open. You can say hi or hello if you're online. Okay, let's start. The subject today we are going to learn is building construction and material. Okay. The topic that we are going to cover is building stones and application and properties of the building stone. Okay. Now let's go to first slide. Okay, we will be covering this topic in format of question and answer. Okay, so let's go to the question itself. So the question is asking what are the various stones that are used in building construction. Okay, Manjula is there. Yes, yes. Okay, we have started the topic. Okay, and the video later will be available offline. Okay, offline means the video will be recorded as normal one and it will be available for watching later on. Okay, so let's start with the application, the various types of stones which are available for building construction. Okay, let's go. So building stones that are used in construction are obtained from various kind of rock. Okay, the sources are igneous rock, sedimentary rocks and metamorphic rock. Okay, now let's see how each type of rock is formed, okay, in nature. Okay, so the first one is igneous kind of rock. Okay, when the molten material, that is the magma, when the magma is cooling, when magma is coming out of the mountain, for example, this is magma, and when it is gradually cooling, what will happen? It will get hardened. Okay, it will get hardened and it will thus get converted into rock. Okay, igneous. Focus the word igneous. Igneous means it is having its source as from fire. Okay, igneous means it is having its source from molten material, which is magma. Okay, magma, when it erupts out and when it comes to the surface, it is called as lava, and the lava, when it gets hardened and thus get durable. Okay, therefore the igneous rock have the properties such as good strength. They are heavy, that is their specific gravity is very good. Therefore they can be used in heavy engineering work, such as bricks are there, breakwaters are there. Okay, then they are used as road metal also. Okay, means aggregate. Then they can be used at docks and piers. Okay, granite is the best example of the igneous rock. Okay, the properties of igneous rocks are they are heavy, their specific gravity is good. Okay, then their strength is also good, then their texture, structure, these properties are really very very good. That's why the main application these igneous rocks find in construction is the heavy engineer works. Okay, granite is the best example. Let's go. Sedimentary rock. Yes, sedimentary rock, obvious the word is suggesting the character, the natural property of sedimentation. Okay, sedimentation is the way, the process by which the sedimentary rocks form. Okay, now see what they are saying, by the force of water. Okay, let's see how the sedimentation takes place. Okay, we are having a river like this. Okay, then what is happening, the river when it is flowing, it is not carrying only water in format of H2O. It will be carrying along with some particles which may be organic, inorganic in nature. Okay, then all these particles, with gradual flow of the river for years, for decades and for the centuries to come, what will happen, all these particles which were previously in suspension, they will get settled at the bottom, river's channel or river bottom, they will get stratified over there. Okay, they will get layered over there. Okay, and since the hydrostatic and hydrodynamic pressure of the river is so high that the loose particle, then they will set upon each other to form a rock. Okay, a stratified rock over there. Okay, this specific rock is called as sedimentary rock. Okay, sedimentary rock usually they are found in beds of rivers or stream. Okay, see, Even this point is also saying that pressure of water, this particle gradually turn into a thick strata. Yes, stratified masses are formed over there and they get hardened. And the reason of hardening for the building stone is it's it is getting with hydrostatic as well as hydrodynamic pressure. Okay, the best example for sedimentary rocks are sandstone and limestone. Okay, now let's go to metamorphic rock. Okay, now metamorphic rock is there. See, these rocks are formed because of the tremendous amount of heat and pressure which is getting exerted upon them. Okay, or combination of multiple such natural forces which can be heat and pressure. See, the parent material. Okay, see, the parent material for the metamorphic rock can be anyone. It can be a sedimentary rock, it can be a igneous rock, and both rocks combine or individually any of the given rock is combined, it forms a metamorphic rock when it is pressurized by tremendous load. Okay, then when we are saying that a sedimentary or a igneous rock, for example, let's say we are having multiple layers of sedimentary rock particles and igneous rock particle. Now they are being heavily loaded and temperature stresses are also taking place. Now what will happen? Whatever the compound which are responsible for formation of those igneous or those sedimentary rock will fuse together. Okay, because of the temperature and pressure, the heat factor, what will do, the fusing action will take place. Okay, the particles are going to fuse and they are going to form altogether new kind of rock. Okay, the rock that we call as metamorphic rock. Okay, means it may be deriving some properties from its parent material, or it may have some new properties. Okay, altogether new property from the parent material. Okay, this specific kind of rock is called as metamorphic. Okay, metamorphism is the process by which this rock is forming. Okay, okay, can you please type in chat whether the stream speed is good, or are you having a good audio over there? Okay, let me just know in the chat. I'm reading the chat simultaneously. Okay, so what are the various engineering rocks that are used in construction? Okay, fine grain granite. Okay, fine grain granite or gneiss. Okay, no means no, no means what? Are you getting the audio clear? Okay, okay. Let me just slow down. Okay, good. See, when we are saying fine grain granite or gneiss stone is used in heavy work. Okay, see, the fine grain granite or gneiss is used in heavy engineering work for their great durability and strength. Okay, see, granite is a igneous rock. Okay, we just saw this, and their specific gravity. Okay, their specific gravity and the property which are suitable for heavy engineering work is there. That's why what we are doing, we are using this, we are putting this to use in engineering work where high amount of load may be exerted upon them. Okay, and in such project what we require, what are the desired properties of the material are there, good durability and good strength. Okay, that's why we go with igneous kind of rock when we are using the stone in case of heavy engineering work. Okay, heavy engineering work means what? When we are having use with respect to road construction. Okay, for example, bridge construction. Okay, or in piers of the bridge. Okay, or dock is there or harbor is there. All these kind of projects, all this kind of works, or all this kind of construction require a material which is durable, then strong, then that doesn't get broken easily, means it has good strength, it has good structure. These properties are provided by igneous rock. That's why we are going for igneous rock in case of heavy engineering works. Okay, then the limestone and sandstone. Okay, limestone and sandstone are sedimentary rocks and they are used in general building construction. Okay, means they are not specified whether we are using in heavy or less strength wherever required. Okay, generalized building construction work is carried out with limestone and sandstone. Okay, okay, then industrial areas like is there, then we go with granite and quartzite. For example, chemical production companies there, okay, or some industrial processes which involve exposure to heat or chemical attack, any kind of chemical attack or heat or any temperature kind of factor is there in any industry, then we go with granite and quartzite for their resistive properties. Okay, they can withstand all those stresses because of fumes, and fumes means chemical fumes. Okay, chemical fumes, they involve some compounds, some uh, molecular activities there which causes disintegration of the material to which they are exposed. That's why what we are using, we are going with strong rocks, okay, which are granite and quartzite. Okay, now in face work, when we are saying face work, we are dealing with elevation. Okay, elevation means the frontal, the visible portions of the building are, that's why we are going to use marble and granite over there. They should be quite strong as well as they should have good appearance. That's why when we are going for stone application in face work of the building, we go with marble and granite. Okay, let's move to next slide. Okay, slate, sandstone and marble are used in paving work and door sills. Okay, and for carving and ornamental work, what we are using, we are using marble and laterite. See, when we are saying carving and ornamental work, the very first property that we desire from a stone is its dressing property. Okay, dressing means what? Dressing means the ability of the stone to get the desired shape, receive the desired shape, and to receive the desired level of polishing is called as dressing. Okay, and since when we are talking about carving mean and ornamental work means, the appearance is going to matter for the stone over there. Okay, that's why the stone which are readily which are readily having the property to receive the finishes, the polish, the shape, okay, the dressing, overall dressing should be used over there. Okay, then compact sandstone is used in fire resistant masonry. Okay, see, when we are talking about fire resistance, actually stones are not that good in case of fire resistance. If we are comparing stones and bricks, okay, then bricks are better fire resistant than in case of stone. Okay, bricks are better when we are talking about fire resistance property. Okay, but in case the stones use is like we have to use stone, then we will go with compact sandstone because of its fire resistance. Then basalt and trap are used in road metalling and paving. Road metalling means, that is, basalt and trap are being used as road aggregate. Okay, they are used as road aggregate. Okay, next is railway ballast. Okay, railway ballast means the aggregate that is put in between the tracks. Okay, for example, this is track, these are sleepers. Okay, you will be seeing some kind of aggregate put it in between the track and below the sleeper. This is what the railway ballast. Okay, then for that, average quality granite and gneiss are used. Then slate is used in partition in bathroom, then window sills, damp proofing work, and roof covering and flooring. For that, slate is being used. And for interior decoration works, for superior building, just like a museum there, a government office is there, okay, where aesthetics are important. Okay, aesthetics are important. At that case, what we are going to use, we are going to use serpentine. Okay, it is, serpentine is very costly, but it gives you a good finish, a good polish, good dressing properties are possessed by serpentine. And in superior building, cost is not an issue. Okay, for interior decoration inside the superior good building, okay, where aesthetic are the prime matter, their cost will not be the issue. That's why we are going to use serpentine over there. Okay, then laterite is there. Okay, laterite is used in general building construction. Okay, let's move to next question, which is what are the desired properties of a good building stone. Okay, for a building stone to be used in construction, what are the various properties which are possessed by that. Okay, let's go to the question. Okay, the first one, strength. When we are talking about strength of a stone, okay, when we are talking about strength, it specifically means compressive strength. Okay, because whenever we are using a material in construction, the very obvious force, the very obvious stress that the material is going to receive is the compressive stress. Okay, for example, let's just have an example. For example, this is stone and this is the stress, the force which is being exerted on the rock. Okay, now since compressive stress we are applying on the stone, what should be the property of the stone? It should possess good compressive strength. Okay, then before using the stone in the construction work, before actually ordering the stone specifically for a construction work, we should test their all properties for the compressive strength. Okay, if the stone is meant to be used in heavy engineering work, then it should obviously possess good compressive strength as well as good specific gravity. Okay, they should be heavy also. Okay, we will be discussing the heaviness property later on. Now remember, when we are talking about strength, the strength of stone is its compressive strength. Okay, the next point is saying stones having uniform and close grain structure are generally possessing good compressive strength. Okay, for example, let's see a simplified example here. For example, if you are having two type of stones, okay, if you are given two type of stone, okay, and if you observe it, then if you find a close grain structure like this, then by the general thumb rule, what you can say, you can say that the stone is having good strength. And if the grain structure looks to be distant, okay, if the grain structure is looking to be distant, if pores are in it, okay, if voids are present in the stone, obviously what you will say that the strength of stone is not that good. Okay, therefore the general observation point here is that you should look for uniform and close grain structure. Okay, that it implies what, that implies what, that the strength of the stone is good. Okay, let's go check the next property out there. Okay, good structure. Okay, the stone is supposed to have good structure. Okay, then the first point regarding structure is it should have uniform texture. Okay, texture means what? Appearance, the feel, the molecular arrangement should be uniform. Okay, the apparent property of the stone which is texture should be the uniform one. Okay, there should not be some different coloration, different gradation when you are looking from, when you break a stone and when you look for the layers inside it. Okay, uniformity of texture should be there whenever you are breaking the stone in any given direction, along the cleavage or whatever. Okay, whatever the direction of breaking of the stone that you are taking place, it should possess uniform texture. Then stratification, yes, when you break open a stone, then you should not some differential layers of material in it. Okay, when you are observing that the stone is having differential layers of material in it, the obvious thing that is going to happen is the stone is going to break apart with some layers, with some weak layer. Okay, and when we are saying that stratified layers are present inside the rock, that it means each layer has differential strength. And when each layer is having differential strength, what is going to happen in field? The weakest layer is going to break open. That's why the putting that specific stone to the use will not be beneficial in that specific project or construction work. Okay, therefore what should not be there? Stratification should not be visible to naked eye. Okay, on a microscopic level there will be obviously stratification that is taking place inside the stone, but for naked eye the general observation should not see the stratification. Okay, then it should be crystalline or have closely packed grains. Okay, it should be crystalline, have closely packed grains. We just saw this point that closely packed grains do have good strength. Okay, and loosely packed grains will be having low strength. Okay, then the appearance of the stone should not be dull. Okay, it should appear kind of bright or kind of appealing. Okay, the appearance of the stone should not be dull when it is broken in a direction other than cleavage. Obviously when you are breaking open the stone along its cleavage, it is going to have good appearance, but when you are breaking it other than cleavage direction, then it should have the the normal appearance. Okay, then yes, the important point, it should be free from cavities and cracks. Okay, there should not be any crack existing in the stone. There should not be any cavities. Cavities means what? Pores. Okay, voids in the stone should not be there. Obviously, what will be happening with the void? Some material gamete locked in inside the pores, or the water will be entering the stone from those pores or those cavities, and the water will be causing some kind of disintegration, and such porous stone, when it is put to use in a building construction, then the porousness, it is the cracks are going to make the, okay, it will obviously be affecting the total service span of the stone. Okay, let's move to property next. Okay, appearance. Okay, when we are talking about appearance, we are specifically focusing the property aesthetics. Okay, aesthetics is the property of stone that we are focusing here. When the building stone is to be used in face work. Face work means appearance. Appearance of the building is prominent in the elevation. Okay, when the stone is meant to be used in elevation, then it should look good. Okay, and for a stone to look good, what are the desired properties? It should be dressable. Okay, it should receive good dressing. Okay, dressing means what? The ability of a stone to receive polish, to receive shape, to receive some specific design over it is called as what? Dressing. A good stone has a property to receive polish. Okay, see, when we are saying that a good stone has a property, should have a property to receive polish, it is kind of ambiguous thing. Okay, because see, when a stone has a property to receive polish, means it has kind of weak molecular structure. Okay, and when we are saying that a building stone is to be used in construction, then the obvious desired property of the stone is its strength. Okay, see, dressing property of a stone and its strength are literally inversely proportional. Okay, so when we are saying that a stone is good in dressing, the obvious point that should come to your mind, that should touch your mind, is that strength is somewhere low. Okay, when the strength is low, the dressing is easier. Okay, the perfect example for this is what? Talc and diamond. Okay, which one is easier to dress? Talc is very easier to dress. You can literally shape the talc stone by using your fingernail, by using a simple nail. Okay, you can even give a specific shape to talc stone by using a knife also. But is it easy to polish or to dress a diamond? No. Okay, because it is hardest. When we are saying the hardest material, it is the strongest material, it cannot be easily dressed. And when we are saying that the stone can be easily dressed, then we are literally talking about its low strength. Okay, therefore appearance, that is dressing property or polishing property of a stone, when we are saying it should be good, then what we are saying that the balance between strength and polishing property should be there. Okay, balance should be there. Okay, since stone is good in polishing, means somewhere we are going to compromise with strength. Okay, let's go to slide number next. Okay, hardness is there. A good building stone should be hard. Yes, it should be sufficiently hard to resist all the abrasive forces acting on it. Okay, see this specific property, hardness, we are going to take it into consideration when we will be talking about the highway material in transportation engineering. We will be discussing all the properties, just like this is there, toughness is there, strength is there, of the aggregate. Okay, of the aggregate we are going to discuss in transportation engineering. But for now, just remember, in properties of good building stone, that hardness is a desirable property. Okay, a good building stone should be sufficiently hard that it should be able to resist all the abrasive forces. Okay, abrasive forces means what? For example, let's say we have installed a specific kind of stone on the walkway. Okay, let's say we have installed some granite, okay, on the walkway. What will be the abrasive forces? The forces exerted by footprints or foot of the pedestrian, any kind of force which is going to wear. Okay, any kind of force which is causing wear and tear, wear and tear of the stone is called as what? Abrasive force. Okay, and a good stone is hard. Okay, a good stone should possess sufficient hardness. Okay, all the abrasive forces should be resisted by it. Okay, let's check out next property. Durability. Okay, when we are saying that a stone should be durable, it means that it should withstand all the atmospheric forces, such as wind is there, rain is there, sunlight is there. Okay, all these forces eventually cause weathering of the stone. Okay, for example, let's keep a stone outside. Okay, for example, this is the stone that we have kept outside, and action of sunlight, then action of wind, then action of water will be causing the stone to get wear and tear, and it is going to lose its particle by the force of disintegration. Obviously all these forces are going to disintegrate the stone, they are going to weaken stone, and obviously such disintegrated stone doesn't survive long. Okay, therefore when you are talking about durability, it is just resistance. Okay, okay, so I have drawn a ohm sign which indicates resistance as in electrical engineering. Okay, durability is resistance to atmospheric forces, atmospheric. Okay, physical and chemicals composition, physical structure and chemical composition plays a major role in durability. Yes, when we are talking about chemical composition, see, the stone will be obviously made up of some different molecule, some parent material. Okay, and chemical properties of that stone are going to matter whether the stone withstand with all those natural forces or not. Okay, if water is going to readily act with the material, the parent material rock, then it is obviously going to disintegrate. Okay, if the stone is kind of dull, then even a wind force can eventually, over when it is working over a year, over a decade, it is going to eventually cause disintegration of the rock, and obviously life of the rock is going to get decreased. Okay, we don't want a short span of the stone. Okay, when we are talking about stone, the stone obviously has a long life to serve. Okay, in that case, what we are doing, we will have to select a stone which has good durability. Okay, next let's go to next property, toughness. Okay, when we are talking about toughness, it is obviously indicating toward impact loading. Okay, it is, we are talking about impact load. Okay, for example, a road is there, and for that road we have used a stone as the road ballast. Okay, or road metal. Then the impact load will be coming from vehicle. Okay, coming from footstep, or coming from any kind of force that the stone is going to receive in its lifespan. And another load, we call it as vibratory load. Okay, vibratory load means repeated load is there. Okay, it is not static kind of load. Okay, it will be coming in form of impact. It is called as what? Vibratory load. And such vibratory load can be resisted by the stone when it possesses good toughness. Okay, therefore when we are going to use a stone as a road metal, the very prime property that the stone should possess is its toughness. Okay, let's go to next slide. Heaviness. Yes, when we are saying heaviness, then we are specifically talking about specific gravity, specific gravity. Okay, specific gravity means what? When we are comparing the material with respect to a standard material, then what is the density of that material indicate its specific gravity. More specific gravity, better the stone. Okay, heavier the stone. When we are talking about good specific gravity, the range, the desired range, 2.4 to 2.8. Okay, and when such heavy stone is used in heavy engineering project, then its lifespan, its service period is expected to be good. Okay, therefore heaviness is another property which should be possessed by a building stone when it is meant to be used in heavy engineering projects. Then dressing. Yes, we just had a discussion, short discussion regarding dressing. Technically, it is the process of converting a stone into desired shape and size. Okay, not exactly size but shape. For example, a stone is to be chamfered. A regular rectangular stone is to be chamfered. Okay, that is, it has to be cut along the corner. Then it is easy when the stone has good dressing property. But the possession of good dressing property means possession of low strength. Okay, then see, the point itself is saying stone which possess good dressing property is weak, and strong stone do not undergo dressing easily. Therefore, previously we said this, dressing and strength are inversely proportional. Dressing and strength are inversely proportional. If a stone is good in dressing, then it has low strength. If a stone is good in strength, then the dressing properties are not that much to the mark or to the point. Okay, let's go to next point. Porosity and absorption. When we are talking about porosity and absorption, that the stone must be having some cavities, some voids, some pores in it, then and only then porosity and absorption is present in the stone. Okay, a porous stone absorb moisture and may get disintegrated due to cycle of freezing and thawing. Now let's see what happens when a porous stone is there. For example, a stone is there, it is having large cavities or so many number of pores that when rainwater is coming or any action of water is coming or even moisture, when moisture is coming and it is entering the void, what will happen? See, when cycle of freezing and thawing are taking place, what is cycle of freezing and thawing? Let's see. For example, in the rainy season, such porous stones were totally filled up with water. They got saturated with water because of the cavities present in them. Now came the winter season when the sub-freezing temperatures are taking place. That is below 0 degree Celsius temperatures are there. What will happen? The stone had received a large amount of water in them. Now what will happen when the water present inside the cracks, inside the cavities, in the pores is getting frozen, then you know the anomalous behavior of water, that is up to 4 degrees Celsius. Let's say from 20 degrees Celsius to 4 degrees Celsius, when we are freezing the water, the volume, what will happens with the volume? Obviously, when you are reducing the temperature of a material, what will happen with the volume? The volume is going to get decrease. But when we are talking about sub-freezing temperature from 4 degrees Celsius to below 0 degrees Celsius, what will happen? Reverse thing takes place that we call as anomalous behavior of water. What will happen? Up to 4 degrees Celsius, the water present inside the cavities, inside the crack, inside the pores is going to reduce in volume. But after 4 degrees Celsius, towards 0 degree or below 0 degree Celsius, what will happen? The water is going to expand inside the pores, expand inside the cavities, and because of that, the water which is now ice will be exerting a tremendous amount of pressure over the stone structure. And what will happen when a stone is stressed? Obviously it is going to break, it is going to disintegrate. Okay, that's why porosity and absorption should be as low as possible when we are going to use the stone where they are exposed to atmospheric action or atmospheric conditions, such as rains are there or any seasonal variation is there, such as temperature variation as in summer and winter, and the monsoon conditions or the rainy conditions there. Okay, therefore what the point is saying, use of such stone is should not be there. Okay, it should be avoided when we are going to use the stone in exposed atmospheric condition. Okay, let's go to next slide. Okay, seasoning. Seasoning means keeping the stone out of its quarry so that all the moisture which is present inside the cavities or on the upper surface of the stone should get removed. It should undergo the action of sunlight. Okay, it should be exposed to air and atmosphere before we are going to put in its specific desired position or desired project. Okay, then next point, let's see. Fire resistance. See, basically a stone do not have good fire resistance. When we are talking, when we are comparing the two building material, which is brick and stone, the least one having the good fire resistance is stone. Okay, stone has less fire resistance, but if we are not having option, if we have to go with stone only, then what we can do? Okay, a good building stone should possess good fire resistance. Okay, desired one. Stone made up of various material tend to disintegrate. Now, what is happening here is, for example, we are having a stone which is metamorphic one. Okay, which is having literal number of type of molecules layers inside it, or sedimentary stone which has some stratification inside. Okay, if the thermal property of the material is varying with the thermal property of other material present in the stone, what is going to happen is the differential expansion is going to take place inside the stone. And when we are talking about differential expansion, then the stratified layer, okay, the stratified stratas which are present in the stone are going to exert some temperature stresses over each other. Okay, and see, such temperature stresses cause the breakage of stone. Okay, that's why we do not want a stone which is made up of various mineral or various layers, various stars of differential material. Okay, see, because of the various coefficient of the thermal expansion, the stone will obviously break. Okay, also there may be some minerals present inside the stone which when exposed to heat, what will happen to them? They are going to melt, they are going to disintegrate, thus their strength is going to get affected in a very vast manner. Okay, that's why we will be avoiding what? We will be avoiding such stone which have differential mineral composition or differential layer or stratification is there. Okay, at least if the stone is having some stratification inside, we should make sure that the coefficient of thermal expansion, that is alpha that we talk about, the alpha should be at least same for all the material which is present inside the stone. Okay, so what we saw today, we saw various kind of stone that are used in building construction work and the desired properties of the building stone. Okay, properties of a good built stone or desired properties of a good building stone. Okay, so that was all for the lectures. If you joined later in this live session, don't worry, the whole lecture will get uploaded as a normal video on the channel. You can check it out later. Okay, we are having telegram channel for the multiple choice question quiz test. I will be uploading quizzes, some tests, objective type questions on the telegram channel. Okay, we also are there on Instagram. Do check the Instagram handle. If you are comfortable in Hindi, then we are also having second channel, that is civil engineering in Hindi, simplified learning. Okay, do check all the things that I mentioned in the description below. Till then, bye bye, thanks for joining.